Well, hello everyone, welcome to the second Ashbourne Maths video in the exponential and log series, 2 of 3. Now in the last video we looked at some of our logs laws. So we had log base 3 of x plus log base 3 of, let's say, y equals, and what we said is things, if we're adding two logs together and they have the same base, then these things inside the logs will multiply together, and so we get log of x times y, and obviously the base is 3. Now one thing I just wanted to point out is that these bases must be the same in order for us to be able to use this rule. So for example, if I am trying to do log base 3 of x plus log base 5 of y, this, well, it doesn't equal anything, okay? I cannot add them together. Remember, these two bases must be the same, and in this case I've got two different bases, so I'm not able to do anything with it. Now, I want to look at a couple of special cases. Firstly, let's think about log base a of a. Now that's going to equal something. What is that? What does that even mean? Well, let's just think of an example first before we do this straight away. So something like log base 3 of 3. What does that equal? Well, remember, this means what's the power? So we're going to convert this into index form, and this log 3 of 3 is asking the question, what power do I need to put 3 to? So remember, the 3 is the base, so 3 is the base in this equation, to get, and the subject of my log is this 3, so in order to get 3, what power do I need to put 3 to get 3? And the answer is obviously 1, right? So log base 3 of 3 is just 1. And now, if I can go back to this log a of a, in the same way, we're asking the question, what power do I need to put a to in order to get a? And again, the answer is obviously 1, right? So log base a of a is 1. So we've got our general results. Log base a of a equals 1, and that's a result that you need to know. Secondly, what is log base a of 1? What does that mean? So it means a to the power of what equals 1, and hopefully you'll realise that the answer is 0. A to the power of 0 equals 1. Okay, so we've got another result here. Log base a of 1. So any base, this is just some unknown base, but it's a number a. If we have log base anything of 1, that is always going to be 0. Okay? Finally, the last little note I want to make is, say we've got a base of a and it's log of x, okay, equals whatever. We have to just make sure two things. Number one, x cannot be 0, okay? X can never be 0. You can't have log of 0. It doesn't exist. And in fact, we can go one step further. X actually has to be positive. It has to be greater than 0. Okay, let's have a little look at our questions. So, question number 1 that I've picked out for us today says log base 3 of 9x plus log base 3 of, and it's a bit more complicated, x to the 5 over 81 equals 3. Okay, so the first thing I can do is notice that these bases are the same, so I can combine these logs using my log law. I'm going to multiply these two things that are inside the logs. So I get 9x times x to the 5 over 81, and remember the base is still 3, and this all equals 3. Now, what would your next step be? How do I get rid of this log? Because I want to solve this, right? I want to find out what x is. I want to get at all of this stuff. So I need to unlog this thing. Now, before we do that, let's just simplify the left-hand side first. I've forgotten to do that. So this is going to be x to the 6 over 9. When I simplify, that equals 3. And now I'm ready to unlog this thing. In order to do that, I'm going to do 3 to the power of the left-hand side and 3 to the power of the right-hand side. So 3 to the power of both sides. Why 3? Because 3 is the base of this log. So just to spell it out so you can see what's going on, this is 3 to the power of the left-hand side. So this is x to the 6 over 9 equals 3 to the power of 3. And then, as we said in the last video, these two things kind of cancel out their inverses, right? So we're just left with x to the 6 over 9. And I've successfully unlogged my left-hand side, which is great. What's the right-hand side become? Well, this is just 27, of course. Okay, and then I can do one more line. X to the 6 equals 27 times 9, which is 243. And so using my calculator, I get x equals 2.498, and that was to 4 significant figures, which is what the question asked for. And I'm done. Okay, we're ready to move on to our second question. Log base a of y plus 3 log base a of 2 equals 5. Now, something to notice on this question is that for the first time we've got bases that are unknowns, okay? So some kind of constant a, and we've been asked to find y. So again, this is kind of quite a classic exam question where you'll take a normal process and maybe there'll be some kind of unknowns which is hoping to bamboozle you, but you shall not be bamboozled. Let's carry on with this. So what can I do? Well, firstly, I want to move this 3 inside the log, okay, because that's going to help me. Because again, I can't combine these two logs using my log law until they're simply log of a. So 3 log of a won't do. So I need to get rid of that 3. But luckily that other law helps me. So I've got log base a of y plus log base a, and this now becomes 2 to the power of 3. That's kind of all in brackets, that's inside the log, equals 5. One more little line to simplify this. 2 to the power of 3 is of course 8, equals 5. And now I can combine my two logs together. So this becomes log base a of just 8y equals 5. And I'm going to again unlog both sides. So I then get 8y equals a to the power of 5. And so y equals a to the power of 5 over 8. And I've finished. On this occasion, I jumped from this line to this line straight away, okay? If you're not sure how I did that, you'll need to go back through some of the videos. Let's move on to our final question. Okay, I've got 3 to the power of x equals 2 to the power of x plus 1. And again, this is slightly different because we've got two index form type things, but the bases are different. 3 and 2 are different bases. Now, in a moment, I'm going to get you to pause the video, okay? Work out what you would do, so get ready for that moment. Now, the first thing I'm going to do to this is I am nevertheless going to log both sides. So log of 3x equals log of 2 to the x plus 1. Now, when I've got these logs without a base, do you remember what this means? This means by default they're 10. We don't need to say it, but they are log base 10. I want you to pause the video, ask yourself this question: why have I done that? Why have I just done this? How's it going to help me? Okay, now, hopefully you spotted that what I'm going to do is use my log laws to get these powers outside of the logs. So in effect, this is a trick that helps me take something that's in a power and move it down from the power. So my next line becomes x log 3 equals x plus 1 log 2. Again, another question for you. How would you then solve this thing? Well, I really want you to understand that log of 3 and indeed log of 2, they're numbers. For example, log of 3, I just did this on my calculator earlier, is 0.477 ... Okay, so this is just a number. So we're now just in the position of having an equation to solve. This is just GCSE stuff now, so I'm going to quickly solve this. Firstly, expand the brackets. Secondly, bring all the x's onto one side. Next, I'm going to factorise this, so take out a factor of x. So I get x, open brackets, log of 3 minus log of 2 equals log of 2. And then finally, divide both sides by what is in this bracket. So I'm left with x equals log of 2 over log of 3 minus log of 2. And I can chuck this in my calculator and I get 1.7095. And that's to 4 decimal places, which is again what the question asked. And guys, I'm done.